In this video, we are going to talk about horizontal scaling. We will look into few aspects of horizontal scaling based on system design and implications of implementing it in a distributed architecture. So, let's start. By definition, it means splitting the load between multiple servers. How do we split the load? By adding more number of machines or servers to the existing one. Let's take an example of e-commerce website like Amazon or Flipkart. Suppose a user is surfing the website, selecting a product and buying some items on the website. So a request will go to the server, execute some logic and save relevant information to the database. As the number of users grow, number of concurrent requests will also increase. Let's suppose the number of concurrent requests go to 10. Can the server handle such number of requests? Yes, it can obviously handle very small number of requests. More users got added now. Number of requests increases to 100. Can the server able to handle such number of requests? Yes, 100 is still a very small number. More users got added. Number of requests increases to 1000. Now, can server handle this number of requests? Probably yes. But if the number of requests increases to million, then a single server cannot handle so much request. Not only concurrent request, amount of data handling in database also needs to be taken care. So in horizontal scaling, we need to take care for concurrent request and data as well. Typical solution is to add more number of machines to handle concurrent request and have a distributed data nodes. Now, in this case, if we allow first user to send request to first server only, second user to send request to second server only, then it would not be fail-safe architecture and we would be wasting resource. So here, typically, we add a load balancer in front of the servers. So all requests now, instead of directly hitting the server, will route to load balancer and from the load balancer to different servers. Advantage of load balancer is if one of the server is down, load balancer will route request to other 3 servers. This solution works effectively in stateless model. But in case of stateful model and distributed data node, we need to think about few aspects. So let's understand that. In case of stateful model, as a user, I will expect to have same set of information irrespective of where data is stored and on which node. So we have to look for data consistency. Consistency could be either strict or eventual. We are not going in the definition of strict or eventual consistency here. When we design system architecture for distributed storage, we have to deal with the implications of cap theorem also. Now, not only data consistency, amount of data read or data write also influence system architecture. Let's quickly summarize. In case of horizontal scaling, it is resilient in nature. It scales very well as the user grow, but it is bit costly in nature due to more infra addition. We need to think about data consistency. Also, possibility of latency in the API calls could be there if the request hop over multiple servers. So this was all about horizontal scaling.